Is my screen visible, Pawan? Okay. So we'll open our software simulation. So last week we discussed how we can interface a 4 by 4 matrix keypad for our password based door lock system. So it is almost finished, like we wrote the code how we can retrieve a particular key from the keyboard. So we wrote till this line, I mean 7 and 8. We have few keys remaining to add. So before that we will test our code whether this key is working properly or what. For that we need support of our UART to see whether the keys are pressed, whether it is the values are coming exactly as what we needed. For that we need to initialize serial communication, and we need to use the serial port feature of the microcontroller. For that I am opening our previous code. From that I am copying things related to serial port. These three lines are initialization of serial port, configuration of serial port. So I am copying that and pasting it over here. If you have doubt on these three lines, you can watch the previous videos. If you want, you will get all information related to serial port configuration. Serial port lies in port C. You can see RC7 and RC6 are the serial port pins. So I am connecting one. Just a second. System seat size 0. Just connecting a virtual terminal to see the things coming through the serial port. So TX I am going to connect it to RX. RX I am going to connect to TX. Also we need to configure, yeah, this is 9600 baud rate. Actually this calculation is for 9600 baud rate. 9600 baud rate per second at 11.0592 megahertz crystal. So we need to adjust our crystal frequency also. So here we need to provide 11.0592. So based on this crystal, we are calculating our baud rate. Then only we are getting this SPBRG value. Okay, now we configured serial port. Now we need to initialize the pins residing in the port which holds serial communication pins, that is port C. Port C we need to initialize port C pins like RC6 and RC7. In the datasheet they are saying we need to initialize port C value as input. For that we need to write tris C value. Tris C value corresponding pins are RC7 and RC6. So RC7 and RC6 remaining pins are not connected. So we need to make RC7 and RC6 one. Remaining we can make it 0. So 1100 0000. So 1100. If you are confused, sure you can open calculator. Go to binary. 1100 will be C. C. Then remaining are 0. Then we can write uh, C equal to C0. Similar value you can put it in port 0 to initialize port pin. So we configured port C's RC7 and RC6 as input, as which is required for UART communication. This is what datasheet tells us to do. Also, we can make port C's RC7 and RC6 pins high state. After that, we configured UART communication related registers DXSTR, CSTA. Then we configured the baud rate at 9600 megahertz. Now we can check our UART by writing a value to UART peripheral. So for that we wrote a code last week. This is that code. Send it to PC. Uh, so send it to PC. We'll send a particular character. Okay. Send it to PC. These lines are simple command lines in order to have a good visual perspective on the code. Like we can differentiate different functions uh, easily. So inside these two lines we are writing our function. So this is send it to PC. Send it to PC will receive one character. So send it to PC is a function which can receive one character, and that character will load to TXREG register. So by doing this, TXREG register will get one value. Upon getting a value to a configured serial port, it will start transmitting the characters. It will start transmitting the characters one by one. Then after transmitting the characters, internal register TRMT will set it to 0. So uh, set it to 1. Why? So we wrote a code like this: while TRMT equal to 0 continue. So what happens is that once you write a value, it will transmit and it will set TRMT value to TRMT register to 1. So we are checking TRMT register status after loading the TXREG value. Okay. So if you want to revise it, go back to previous UART related videos. Yeah. So now we can check this function whether it is transmitting a value or what. So we can do like this. Just we can write it over here, and we are just sending one character, a capital letter A we will send. Just compile this code, then load it to Proteus. Yeah, compilation is completed. Just hit play button. Okay, properties. We need to specify the program was not there in password based door log software distribution default production. Yeah, this is our hex code. Okay, now hit play button. Yeah, it is sending the character A. Yeah, you can see that. So it is sending continuously. Okay, in our code we missed something. We need to write one while loop. So while one. So all these things should be inside while loop. Now our serial port is ready. It is showing which character we send. So similar way we can use This one, read keyboard function. We wrote a function, right? Read keyboard. And we want to know whether the read keyboard function is working properly or not. Okay. Now the result value is key value. After you can see the key value is a local variable. We need to know whether we are getting the right key value. For that we can use send to PC function. Okay. So this is the basic software driver development coding. After after we are completely sure that we have the properly working driver for keyboard, we can go to software building, like how we can plan the operating system, how the operating system should work. So right now we are trying to interface the keyboard with the microcontroller. So at this stage we are checking our code whether this is working properly or what. So key value, we are sending the key value here. So what happens is that after pressing a key, you are going to get a key value. So what I will do is door status equal to close, lock equal to disable. We have some status over here. So anyway, this read keyboard function is going to work. So what happens inside the while one, read keyboard will be calling. So if you are pressing, it will return some value, and send it to PC function will should print that value. Let's see whether it is working or not. So yes, we have the initial testing letter A present now. You can see the keyboard scanning happening. Now I am pressing 7. It is not working. What is happening here? We'll do one thing. We'll do this thing previous to the tri-state register value port B. We will set it at the first, then we will set the tris value. Before that we will make the tris values 0, like we need to load it. Similar thing we will perform here also. Initially we will make tri-state registers value 0, then we will load the port value, then we will make the tri-state back to the required value. Let's see whether it's helping us. Column value equal to port B, row value, column value. I will tell you what is RBPU. RBPU is internal pull-up resistor enable register of our microcontroller. So we are enabling it. Some issue is there. RBPU. To know. So these are the internal registers and its value. If you don't know any registers, how it is named inside the compiler, you should have to come here and check. I will open our data sheet. So I will explain what is happening now. So this is our data sheet. We need to go to ports, and in that ports you have to go to port B register. So here you can see each of the port B pins has a weak internal pull-up. A signal control bit can turn on all the pull-ups. This is performed by clearing the RBPU inside the option register. Okay, so we have a register called option. Inside that we have a particular flag called RBPU. So you can see that option register somewhere. So yeah, see this is the option register. Inside that seventh bit is RBPU. So we need to clear it to have a pull-up resistor internally on these pins. So when you are interfacing some input devices to any microcontroller, we need to provide a pull-up resistor in order to have a proper voltage status on that particular pin. So we need to enable it. Uh, let's see how can we enable it. It is inside the option register, so we need to check where is this option register. So control F, PTION. So we find it out. Option register is here. Inside that option register, PS0, PS2, PSA, timer we saw. Yeah, this is the value NRBPU, it seems. So if you want to access it bitwise, you have to find out exactly what name they used inside the software declaration. So NRBPU is the value. Yeah, now you can see the error vanished. Now just go for the compilation. Yeah. Now let's see whether our code is working. Otherwise, we have to debug it once more. Yeah. Initial value A is ready there. Now you can see proper voltage levels over the micro microcontroller's port B pins. Now let's press A. Yeah, you can see 7 is coming. Now press 8. You can see 8 is coming. Some bug is there definitely because it is continuously repeating the value because we are in the while loop. Okay, so while loop we need to now we can finish all the remaining keys, right? So what we can do is we can copy paste these lines. So for 3 lines it should be E only. Now E0, D0. Next what? So initially we got E0. Yeah. For 7 we got E0, right? That's how. Double one, sorry, triple one zero is E0. Now if you press 8, this line is going to become 0. Double one zero 1. Now if you press 9, you are going to get this line 0. That is 1011. What is 1011? Go to binary 1011. That is B. Okay. Now you can write B0 over here. So this is division, uh, but we can tell something. Maybe set button. Maybe we can call this division button as S for set or clear or menu kind of thing. We can call this division button as M. Menu template I will put. I am going to call that button as menu. We can represent that button with one character called M. Okay, so if you press this one, what it is going to happen? I think I made some mistake. Let's see. For 9, this is the button, and this is the line which is going to 0, right? So this is the button. This is the pin which is going to become 0, which means 1011. Yeah, 1011. We are getting B, so we need to modify. Yeah, same thing we modified, but we referred a different line. So now menu button, this wire is going to become 0, this pin is going to become 0, so 0 1 1 1 is going to 7, 0 1 1 1 7. You can write uh, column value 7. 0E column value 70. 70 will return M, which represent menu button. Okay. Now we have another row value. Need to find out another row value. So here it should be else if only. So 0 is complete. 0E means this column, this row is complete. Now we have this row. This row value will come like 1101. If this row is getting pressed, all the keys 4 5 6 and this multiple will get 0, right? So RB1 is going to become 0. 1101. Going to calculator. 1101. What is the value? 1101, which is D. So we need to make all these lines D, because all the keys are going to give D, but column value will change. Let's see what column value we are going to get. So this is the button, so this line is going to change. If it is changing, double triple one zero, triple one zero we already know it is E. Yeah, it's E. So this value will get repeated, right? Okay, so we need to update keys only. Which are the keys there? 4 5 6 and multiple. So for multiple, we will keep menu. uh, After menu we will keep some scrolling button, up button. I don't know whether we are going to use these buttons for this project, but we'll have a proper library for keyboard, software library for keyboard. We can keep this button as down, and we will keep this last button as set or exit. Set or exit. If you want to save some value, you can press this value key, or if you want to exit, you can press this value. Um, that you have to maintain, I mean, plan in software. So 4, 5, 6 up, we will use U for up. Okay, so we need to modify 4, 5, 6 U. Let's see whether these keys are working or not. We will debug once again. We'll try to simulate once again. Play. Now the latest keys which we wrote are 4, right? Yeah, 4 is coming, 5 is coming, 6 is coming, up is coming, M is coming. Instead of 9, 8 is coming. That is a software issue because we haven't updated there. We have to update it to 9. Then it will come. Now 8 is coming. 7 is coming. Yes. Now we have few more things remaining. Now after 0 we got 0D. Now we will get 0B. How it is becoming 0B, you know, right? This is the row which is going to uh, which we need to take care of now. So this is the pin which is going to be 0. So 0, sorry, 1 0 1 1. Go to calculator. 1 0 1 0 1 1, which is B. So we are putting B over here. Now things are going to be similar: E0, D0, B0, 7 0. Now just we have to identify one, which is those keys 1 2 3 and down. 1 2 3 and D. Next one is after 0E, we are going to get sorry, after 0B we are going to get 7. You can compare here, right? See, E0, D0, B0, 7 0. Likewise we are going to get here also 7. See, 0B after 0B it's 7. Values are going to be similar because the same columns are going to work. So the keys are okay. We can make one change. We can create exit button over here. This is going to be the exit button. I mean this equal to button. This is set only. Edit. We will make separate buttons. Okay. Set only. This is 0. Now we have one more button remaining. We will call that button as clear button. Clear. So clear, for clear we will use C. Okay. So first character it is going to be C. Second it is 0, 0. And third it is exit. For exit we will use E. Okay. E. Now we have one more button remaining, right? Okay. Set. Set button. Set. Okay. Now everything is ready. Our keyboard driver is ready. Let's check all the pins. Sorry, all the buttons. 7, 8, 9, menu, 4, 5, 6, up, 1, 2, 3, D, C should come, C, 0, exit E, set S. So now our keyboard is working properly. Our software for keyboard is ready. Now we can plan for the project related stuffs like how the system should work. Now we have the keyboard. Now we have the other peripherals like LED, buzzer, lock, everything we have. Now we need to plan the software. So whenever the system is powering up, it should close the door. So it is imagining that the door is closed. Okay. So whenever we first initialize the door, initialize the system imagines that this door is closed. There are so many other ways to uh, build this project. So right now we are doing some basic stuff only. So how this project should be there are many ways we can imagine. So currently the system assumes that the door is closed, so door status equal to 0, which means close. So what it is checking now, door status equal to close, lock is equal to disabled. So what is lock? Lock means RD7, disable means 0. What happens then? So 0 means motor is not rotating and lock is locked. Okay. Now else, if lock is equal to else condition, if door status equal to open, else means door status equal to open means what, 1. If door status equal to open, lock is equal to enable, so it will unlock. So we need to make this else condition by checking the read keyboard. Okay, we need to read the keyboard, then only we can make a decision to unlock. Okay, lock equal to enable means unlock. So we will write a function to write a function for unlocking and locking the door, so that we can use it properly, like without any doubt. void lock door. So lock door means this one, lock equal to disabled. We need one more function to unlock. Unlock door, lock equal to enabled. So if you press control space, if you type and press control and space together, you can get some suggestions. From that suggestion you can take. So I am taking enable here, lock equal to enable. So yeah, I am going to call this function. If door stat is equal to close, lock the door. If door stat is equal to else condition, it should be unlock door. Now we need to plan our operating system in a way that it should read from the keyboard for values. Okay, it should read 4 key values. Like we have a password called 1234. So we need to read 4 values from the keyboard, and we should compare those 4 values with the existing password. So we are going to write a function called read password. Okay. Or we can write void check password void, which means that when I am writing this function, in my mind I am thinking that this function is going to read the keyboard and compare that readed value with the existing password. So in my mind, I am thinking in a way that this function will read values from the keyboard and it will compare those 4 values with this existing 4 values. Okay, so this is what this function is going to do. Check password. So what check password has to do, it has to read 4 key values. Okay, 4 key values from the keyboard. So what we can do, we need to read keyboard 4 times. We need to read keyboard 4 times. So we need to have a mechanism so that it should read 4 key values. For that we need a variable called, can create char variable, char count. 4 values we need, right? 4 values we need. So we are writing count, a variable we created count, and we initialized it values to 0. For local variables we use small letters. Count we are going to see how we can use for loop here properly for reading for loops application here. For count equal to 0, count less than 3, we need to only 4 key values, right? Count less than 3, count plus plus. Now we can read key values. So what we can do is we can call read keyboard. Read keyboard will come up with a value, right? Read keyboard comes up with a value, but the function we created, the read keyboard cannot return a value because see the type of read keyboard function, it cannot return a value. So we need to modify read keyboard in order to return a value. So we are going to type char over here because it is going to return a character. See, there are so many characters, so we need to return character over here. For time being, I am commenting this line. We no longer need this exercise to be done, like we already know our keyboard is working. So what at the end it is going to return key value. So return key value. So it is going to return the key value. If you press 7, it will return 7. I mean the key value is getting returned. So at the end of the execution of this read keyboard function, we'll get the key value returned. So we wrote return key. Paudan? Yes, yes. Yes. Yes, Paudan. Yes, Paudan. Can you hear me? Hello? Paudan, can you hear me? Hello? Okay. Can you hear me now? Okay. Oh, okay. Maybe you can watch the video after some time. I recorded it properly. It is properly recording now. Not a problem. It is properly recorded. You can watch it after maybe 10 or 15 minutes. I will upload the entire video. Okay. How about now? Okay. Yeah. So it's properly recorded. You can watch it. So what we did is like we modified our main routine and we created some functions called lock door, unlock door, check password. So right now we are in check password. So what check password is doing, it has to read 4 key values from by using read keyboard function, and it has to compare those readed values with our existing password. Then only we can make our decision if it is passed, if the password is passed, then we can unlock the door. So this is what we are going to do now. For that we created a variable called count. In that count we are read keyboard 4 times from 0 to 3. uh, then we will have 4 key values. For that we need to store those key values. To get those key values, we modified read keyboard function. Initially read keyboard function was void type, void read keyboard void. Now we have char read keyboard void. Char means unsigned char. Unsigned char positive. Okay. So at the end, keyboard function will return one key value. So we have to receive that key value here. Okay. For receiving that, we are using a variable called, not variable, we need to use an array called user input. User input is an array of size 4. Okay, so 4 variable should be it should be capable of reading 4 values, user input. So initially what happens is that user input of 0 will get its initial value. Okay, user input of 0. So when count is equal to 0, you are pressing one key, right? Maybe if you are pressing 7, it will come and sit inside. It will sit inside this array. So if you are confused with array, I will explain that. Let me open Paint. Okay. So when you write user input equal to 4, user input equal to 4, compiler is going to reserve a memory space for you, which is of size 4. Okay. If you're not telling compiler to initialize it, some garbage value would be there. Some values like 0 or FF or some values would be there. If you want proper initialized, you can write it equal to 0, like user input equal to 0 you can write. It will make all the memory location 0. So right now it would be some garbage value. So what happens now is that for count equal to 0, count less than 3, count plus plus. Initially value of count equal to 0. So we are writing it in a way that user input bracket count equal to read keyboard. So what is the initial value of count? It is 0. So user input of 0 is going to read keyboard. Read keyboard will return a value, right? If it is returning 7, it is going to be 7. Next, it will increment. Count value will get incremented. Now will become 1. Now it is checking whether the count value is less than 3. Yes, of course it is less than 3. It is 1. Then user input of count. User input of count means user input of 1. So this is 0, this is 1, this is 2, this is 3. Array always starts from 0. Okay, when you initialize, it should initialize from 0 to 1. Okay, so now 1. If you press a key value of 8, it will be 8. The same happens for the other also. Now it count will get incremented. If count will get incremented, right? So after that, count equal to 2. In count equal to 2, same thing will happen. If you press some other key 5, it will be 5. Then count will become 3. Then it will get a value, maybe if you press 6, you will get 6 over there. Now it will again increment, but the condition will fail. This thing will come out. I mean, the control will come out of the for loop. So after this for loop, we have 4 values inside the user input. Now we have to check. Now we have to compare this user input with this password. Okay. How we can do that? We can check with the help of if condition. If there are many ways to compare the content of a array with an array. So I am using one basic simple method, user input of 0 equal to uh, password of user input of 0 equal to uh, password of 0, and so this is a logical operator. You will get to know what I am writing. So what we compared, 0 compared, we compared the 0th position value with our existing passwords 0th position. Okay, and we are going to compare first position with the first position of our password, and we are going to compare second position with the second position of our password. Now we are comparing with the third position of password with the third position of password. If this is success, I mean 0 contains the same value as in password 0, and first position contains same value as in our passwords first position. If it contains second position value as same as password second position, third position as same as third position, we will get a true value. Okay, so what what we can do now, we can directly call unlock door here, or we can write a variables value like we have one status, right, door status. So we can use this door status. So what we can do now, we can write it like this: door status equal to uh, door status equal to um, we can write open, you can use, or enable. Okay, we can use open. Just checking, open means one. Okay, okay, door status equal to open. Else you can write, if the password is failed, you can write door status equal to, if it is a single line you can write it directly without this curly bracket, but I'm anticipating some changes in the software code, that's why there might be multiple lines if we are modifying this project's code. So I am keeping curly brackets same. Close. Yeah, so door status equal to open, door status equal to close. Now check password will compare and uh, compare and will uh, write door status variable with the right value, open or close. Now in our software we can, it will work properly, like if door status equal to close, it will lock the door. If door status equal to open, it will unlock the door. So what we have to do is we just have to call check password uh, always, check password always. Now we have few status LED too, right? Now we have few status LED to display some statuses. So there is an LED unlock. So there is an LED unlock. We need to turn on that LED. So where we will turn on unlock door. So this is unlock LED. So unlock LED should on. Also we have one buzzer also. We have a buzzer. We need to make a beep sound. For beep sound, we wrote a code for the last project. We are copying that code from here. We will keep it somewhere here. So this is beep sound. For that beep, delay is not present. We need to copy the delay function also. Yeah. We copied everything. Yeah. Now we have delay buzzer beep function. We will use this beep function inside this. So once the door is unlocked, we will get a beep function. Also, we need to make sure about the other LED. LED lock LED is there, right? So lock LED sometimes if it is uh, on in some cases because the door is locked, LED should be uh, turned on. So what we need to consider about that LED also, we need to make sure that lock LED is off. So the same thing happens in when the door is getting locked also. Unlock LED is going to off and lock LED is going to on. So this is how we plan our software. So when thinking, you will get many more idea. While executing the software on hardware, you will get a different idea. Likewise, we are getting software updated. So you can always update your software code after you are getting much idea and many different concept after executing the code. So we'll compile this code. I am anticipating a problem that is called wait, warning, implicit declaration, expected identifier bracket. Okay, okay, I'm missing a star here, slash star. Okay, okay. So what problem I am anticipating is that there is a concept called debouncing, key debouncing. I will key debouncing. Okay, so this is what key debounds. This is a hardware related thing which we need to consider while writing software codes for switches or keyboard. So what is button debounds or key debounds? So button debounds or key debounds is the intermediate sudden changes happens in the button line. So you already know if button is not pressed condition, it should be in logic high, right? It should be in logic high. If it, yeah, you can see in our software, if our button is not pressed, you can see the lines high. Okay, so whenever you are pressing the button, you are not pressing quick, even if you are pressing quickly, there should be some contact happening and not happening, like uh, the metal plates of the switches will get in touch and it will lose its contact. So this connection and disconnection happens in millisecond time. So you will get a waveform like this. It is going low and it is coming back to high, again it is going low, at the end it is going to be in low condition. So when you press a switch, when a human being presses a mechanical switch, this kind of waveform will happen. So the software will detect it as a multiple press. Okay, so we need to write our code in a way that it should avoid this button button bounce. So we will implement that code in upcoming lecture. So button with button debounce, we will test our software, whether it is working fine or not. Thank you for the day.